Hey everyone, and welcome to this explainer. So today we are tackling a really massive, absolutely fascinating topic, artificial intelligence. We hear the buzzwords literally everywhere lately: machine learning, neural networks, LLMs, but what do they actually mean? Well, today we're going to decode the AI universe together. We're breaking down the core, fundamental concepts of AI completely from scratch, turning all those kind of intimidating buzzwords into clear, actionable reality. By the end of this, you're going to feel totally confident talking about and understanding the tech that's actively shaping our world right now.
Here's our roadmap for the breakdown. Think of this explainer like a set of Matryoshka nesting dolls, right? We're going to start with the outer layer, 1, the real world of AI. Then we'll open it up step by step to 2, what is machine learning? 3, types of machine learning. 4, deep learning and neural networks. And finally, we'll zoom all the way down into the innermost core, 5, generative AI and the future.
Okay, let's dive right into this, starting with Section 1, the real world of AI. So, artificial intelligence is our biggest, outermost nesting doll. At its core, AI is really just technology that allows computers or systems to perform tasks that typically require human intelligence. Think about the things we as humans are naturally good at, right? Recognizing patterns in a messy room, understanding when someone speaks to us, or just looking at something and identifying what it is. AI is basically the giant umbrella term for getting machines to mimic those exact human capabilities. And listen, this isn't sci-fi anymore. It's literally everywhere. If you unlock your phone with Face ID or ask Siri about the weather, you're directly interacting with computer vision and speech recognition. When you're scrolling Amazon or Blinkit, AI is the thing driving those hyper-specific product recommendations. When Google Maps or Uber gives you an incredibly accurate ETA based on rush hour traffic, yep, that's AI. Even software developers are using tools like GitHub Copilot to help write code. If you're using modern tech today, you're interacting with multiple forms of AI every single day, for sure.
So let's open up that first stall to reveal Section 2, what is machine learning?
Now, this brilliantly illustrates the massive paradigm shift that machine learning brings to the table. In traditional computer science, a human programmer writes strict logic. You give the computer data, you give it explicit rules, and it spits out answers. But machine learning, it flips this entirely on its head. With ML, you give the computer vast amounts of data and the answers, and the algorithm actually figures out the rules by itself. It literally learns from the data rather than relying on a human to hard code every single possible scenario. It's a real game changer. This whole process basically happens in 2 distinct steps. Imagine you work at a bank, okay? And you want an AI to predict if a loan should be approved. Step 1 is training. You feed the algorithm thousands of past loan applications. That's your data. And whether they were accepted or rejected, those are your answers. The algorithm analyzes credit scores, salaries, education, and finds the hidden patterns. Once it actually forms a logic model from all that, we move to step 2, which is inference. This is where a brand new applicant walks into the bank, and the model uses that newly learned logic to predict whether their loan should be approved or not. So how exactly do we train these models in the first place? Let's move to Section 3, types of machine learning. Broadly speaking, machine learning is divided into 3 main categories. We've got supervised learning, which uses neatly labeled data; unsupervised learning, where the machine is just left to find hidden patterns in raw, messy data; and reinforcement learning, which is this really fascinating trial and error process based on rewards and penalties. Let's look a little closer at these. In supervised learning, we give the models structured data where the inputs and outputs are very clearly labeled. This generally solves 2 main types of problems. First up is classification, where the goal is just sorting things into predefined categories. A perfect example is your Gmail spam filter looking at an email and categorizing it as simply spam or not spam, or an AI sorting images into cats versus dogs. The second type is regression. Here, we aren't sorting categories anymore, we're mathematically predicting a specific numerical value. So when apps like Zomato or Swiggy predict your food is going to arrive in exactly 43 minutes based on past delivery data, they are using regression. Now, what's really interesting here is how we can use totally everyday analogies to understand these incredibly complex algorithms, especially when it comes to our third type of learning. And that brings us to reinforcement learning. Guys, it is exactly like training a pet dog. When you teach a dog to sit, you give it a treat when it does it right, and you don't when it gets it wrong, right? In reinforcement learning, the AI, which we call an agent, interacts with an environment. It makes guesses, and we give it positive mathematical values, or rewards, for good actions, and negative values, or penalties, for bad ones. The agent's only goal is to maximize those rewards. This is exactly how we train AI to win a game of snakes and ladders, master chess by sacrificing pieces for a long-term win, or even operate self-driving cars.
All right, it's time to open the next Matryoshka doll. We're moving to Section 4, Deep Learning and Neural Networks. To really understand why deep learning exists, we have to look at the data itself. Traditional statistical machine learning is fantastic if your data is neat and structured, like an Excel spreadsheet of bank loans. But what if you want to analyze messy, unstructured data? Things like a massive folder of raw YouTube videos, millions of chat messages, or live camera feeds. Traditional ML struggles heavily here because defining the exact features of an image, like telling a computer mathematically what a human eye looks like, is incredibly difficult. And that is exactly where deep learning takes over. Deep learning relies on artificial neural networks, which are actually inspired by our brain's own neurons. To understand how they work, imagine a college grading system. In a neural network, your data, let's say a student's test marks, are the inputs. Now, the college decides that end-semester exams are worth 40% of the grade, while small class tests are worth way less. In a neural network, this level of importance is represented by parameters called weights and biases. Finally, all of this calculates together to give a final CGPA, which represents the neural network's prediction or output. So the absolutely crucial point here is how this network actually gets smarter, which happens in two relentless phases. First is forward propagation. Data flows forward through the layers of neurons, applying those weights to make a guess. Second is backward propagation. The network compares its guess to the actual correct answer, calculates how wrong it was, a metric we call loss, and then sends that information backward, slightly adjusting the weights and biases. It's literally learning from its mistakes. By doing this millions of times over vast data sets, the predictions become astonishingly accurate. Depending on the task, we use different neural network architectures. Feed-forward networks, or FNNs, process data in a straight line, great for basic tasks like medical diagnosis based on clear data. Recurrent neural networks, or RNNs, possess a sort of memory. If you feed it the sentence, Raj is happy, it remembers the word Raj when it's processing the word happy, which makes it great for sequences and language translation. Then you have convolutional neural networks, or CNNs. These are the undisputed kings of computer vision. They analyze massive grids of pixels to instantly process images and video, which is how self-driving cars see the road. And finally, transformers. These use a mechanism called attention to grasp deep, complex context in huge blocks of text, understanding exactly how different words relate to each other. And that brings us to the final innermost doll. Section 5. Generative AI and the future. Let's see how this builds on literally everything we've talked about so far. All the AI we've discussed up to this point analyzes past data to classify things or make predictions. But generative AI, or Gen AI, it takes all that deep learning infrastructure and flips the output. Instead of just predicting a number or sorting a category, Gen AI generates entirely new, completely original content, be it text, audio, video, or images. The landscape of Gen AI is just exploding right now, with different tools mastering different creative and professional spaces. For text generation, we've got heavyweights like ChatGPT, Google's Gemini, and Meta's Llama. For generating stunning images out of thin air, we rely on tools like Midjourney, DALL-E, and Stable Diffusion. We even have AI generating highly realistic video like Sora, or acting as your own on-demand software developer, generating complex code through GitHub Copilot. To fully grasp this whole ecosystem, let's just lock in our mental model of the terminology one last time. When we talk about teaching machines to understand, interpret, and generate human languages like English or Hindi, we are talking about NLP, or natural language processing. The specific tools we use to achieve NLP today, those massive transformer networks trained on internet-scale text data, are called LLMs, or large language models. So ChatGPT is an LLM doing NLP. On the flip side, when we teach AI to interpret visual data, like images and video, usually using those convolutional neural networks, we call that computer vision. And there you have it, the whole shebang. We've gone from the broad concept of artificial intelligence, down through the logic-finding engine of machine learning, into the complex, brain-inspired layers of deep learning, all the way to the creative powerhouse of generative AI. AI is absolutely no longer just a buzzword. It's a set of distinct, incredibly powerful tools that are learning from data, finding patterns, and generating entirely new realities. So I want to leave you with this final thought. Now that you actually understand the mechanics behind the magic, how are you going to apply these tools to your own life and career to build the future? Thank you so much for exploring the AI universe with me today. Keep learning, keep experimenting, and I'll catch you in the next one.